Alright y'all, here is another video about the properties of exponents. You can actually find this in section 1.1.2 if you go to the chart right there. I'm really just going to be talking through it. You can feel free to just copy the chart down if that's more your style, but yeah, I'm going to just be going through it. So I'm actually going to start with the last property first. So lesson, I believe this is 3, properties of exponents. Okay, so the first thing we need to get clear is that you can show exponents as either fractions or as a mix between a radical and a power. So our first property states that x to the m over n power is equal to the nth root of x to the m. So you'll see why in the homework this is actually a much more convenient way to write exponents than this. This is nice for familiarity. We know the radical symbol, we're used to that, but we really should start getting more acquainted with this. So if we want to have, actually there's 2 great examples, one with a variable and then another one with some numbers, so we can see how much more useful it is to do one over the other at times. So our first example is just looking at x to the 4/5 power, and we find here that n is equal to 4, the value on, 5, the value on the bottom, and then m is equal to 4, the value on the top. So just rearranging it in this case, we have our radical symbol as well as our x. We know the m is going to be 4, the n is equal to 5, so it's the 5th root of x to the 4th. Easy peasy. Let's go to the next one. 8 raised to the 2/3 power, and we're going to actually evaluate this thing as one number, one nice whole number. So if we are looking back at here, we know that the n is going to be our bottom value, which is 3. M is going to be equal to 2, which is our top value. So we have that this is equal to 8 squared, and we're looking for the 3rd root of that. So we can simplify down the 8 squared and know that this is just 64. And so this is saying, what number do we multiply by itself 3 times to get to 64? Well, if we break this down, we can see that if we multiply 4 by itself 3 times, we get that 64. So we know that the cube root of this is equal to 4. So that's this property, showing how a fractional exponent can be the same as a radical. Next property, we're just going to go right down the list. So we have x to the m times x to the n is equal to x to the m plus n. So all this is saying is if we have a number with the same base, 2 numbers multiplied together with the same base but different exponents, can actually add those exponents up, leave the base the same. So our example for this, I'm actually going to be a little more explicit with how I split this up. So for our example here, we're going to do 2 the same way. So if we have x cubed times x to the 4th, well, our m is 3, our n is 4, so we're just adding them up. So x to the 3 plus 4 power. So this is just x to the 7th. There we go. So in numerical, Example would be something like 2 to the 5th times 2 to the negative 1. Same base, we're looking good, so we can just add these two together, but you need to be careful about the negative value going on with the second exponent, so 5 plus a negative 1. So this all comes out to 2 to the 4th power, or 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. On to the next one. If we have, let's do it right here. X to the m divided by x to the n. So same base, different powers. What we can do is actually subtract the bottom power from the top power. Something like x to the m minus n. Okay. So we're going to do a variable example. We're also going to do a numerical example. So we can start off with x to the 10th divided by x to the 4th. All we're doing here is subtracting the bottom power from the top because we know our base is the same, x. So we have x to the 10 minus 4. That's just going to give us x to the 6th power. So next up we're going to just do another numerical one. We can have 5 to the 4th divided by 5 to the 7th. So in this case, we subtract the 7 from the 4 because our base is 5 on both. So we've got 4 minus 7. So 4 minus 7 is going to give us a negative 3. And so this is as much as we can simplify it right now with all the properties we know. So I'm going to introduce another property, and we'll actually be able to see how we can simplify this down into the most simple case. We did this during our mock day actually for our example, but here's just another review in that. So if we have an exponent with just any base, but we know it's raised to the negative power, we can actually turn this negative power positive by putting it in the denominator of a fraction. So x to the negative n power is equal to 1 over x to the positive n. So if we wanted to go back and actually fix this one up, we know that our base is 5, our exponent is negative, so if we just put it underneath it, we're good to go. In fact, this can now be simplified down to 5 over 5 times 5 times 5, or 1 over 125. So we'll do one more example with a negative exponent, but in this case we're going to do it for a base of x. So x to the negative 2 power is just 1 over x squared. Alright, and finally there's one more that we need to check out, and it is the property of 0 for exponents. So this one says that if we have any value raised to the 0th power, that's always going to be equal to 1. Doesn't matter what this is. So for example, we could have 2 to the 0. That's equal to 1. We could have 4 to the 0. That's also equal to 1. We could have 1 billion to the 0th power. And you guessed it, it's always going to equal 1. Okay. So this should help you get through a bit of the problems. Oh, there is one I actually forgot. I can't believe it. Power of a power rule. So this is a pretty good rule to know. If you have some value raised to a power and then you raise that exponent to another power, all you have to do is just multiply those together. So we get x to the m times n, like so. So all you need to do in order to do this is, well, let's just take a look at 2 examples. So our first one will be x to the 4th raised to the 3rd power. So we have x raised to the 4th, and then we cube that. So it's almost like saying x to the 4th times x to the 4th times x to the 4th. So if we were to use our property up here, if we do x to the 4th times x to the 4th times x to the 4th, that's x to the 4 plus 4 plus 4, 12. So same idea here. We just raise our x to the 4 times 3 power. So this thing just simplifies down to x to the 12th. And there we are. We can also do a numerical example that might be a little more comfortable for some of y'all. So we'll have 10 to the 5th raised to the 6th. So in this case, we'll just multiply them together again. 10 to the 5 times 6 power. So that's just going to be 10 to the 30th power, 10 with 30 zeros behind it. Okay? Alright, so now we're actually done. This should be enough to get you through the individual work. Remember, these are all the properties you need. If you run into an example that does not follow these properties, you actually cannot simplify it anymore. So you'll notice that actually happening in part B of 112 as well as part F of 112. So be careful about that. Know exactly what these are saying. Same bases, always the same base. And we're only talking about multiplying exponents or dividing them or raising them to powers, which is another way of showing repeated multiplication. So hopefully this helps out. I will recommend for 114 looking at the last video I posted. The homework help will also help you pretty well with this. All right.